Hi, welcome to another session on computer network, which is a routing algorithm. So, in the previous sessions, we are discussing about this: what is the functions of network layer and what kind of services offered of the network layer. We discussed in the previous session. So, while discussing about these functions and services, the major concepts of this one, it is purely based upon this: choose a routing path, the values, the packet is transmitted from source to destination. So in this session, we are discussing about this: what kind of mechanism we are using. This information is transmitted from one station to another station, one packet to another packet. So that we are discussing the unless the shortest path, which is a routing algorithm we discussed in this session. What is routing algorithm? So in the routing algorithm, so while we discussed in previous sessions, so when information is transmitted from this A to B, we have to choose the shortest path values only. So what is the shortest path? So first we need to analyze in the routing algorithm mechanism. So what is routing algorithm? Assume that one. So we having as a n number of routers are there. For example, we having as a multiple routers are there. For example, information into transmitted from like this. Right. So here A, B, C, D, E and F. So I need to transmit different information from A to F, which means A acting as my source, which is transmitter, and F acting as my receiver. So I need to transmit information from A to F mechanism. So I need to choose the shortest path. So in the A to C is the shortest path, or A to B is the shortest path. So if we found A to B shortest path, then I'll go for this either B to C value or else C to D value. Next, D to F value. So if we having as a D to E combination is there, so we need to check the combination of D to E is the shortest path or else D to F is the shortest path. So accordingly, we have to choose a shortest path mechanism. So all the information we are storing in a one specific table that we calling as a routing table. So what is routing table? In the routing table, having as information which stores information from each and every entry of the packet is moving from this destination. We have to enter of each destination services, which we have to maintain the routing IP packet values only. So but this routing table maybe a static value or dynamic value. Systematically we can able to change the value, that we can calling as a static or dynamic mechanism. And so what is a static routing table? So this table contains information manually, but administrator enters the what kind of routing information we have that one. So each and every time we have to manually enter the information. For example, previously you see this one, information is transmitted from A to B or else A to C value. So information is transmitted from A to C value. What kind of packet we consumed? We consumed 2 or we consumed 3. So all the information we have to enter the manually. So administrator is maintain that kind of information, that we calling as a static one. But when we go for this information, we go for systematic manner in the based upon the backend algorithm is running, that we calling as a dynamic algorithm. So that we calling as a reporting progress or open switch OSPF or a broader gateway protocol. So that kind of different kind of routing protocol we are using that one. Assume that one we have, for example, we having as a 5 packets or the 5 routers are there. The administrator can able to manage that one. But we having as a 10 packets are there. We having as 100 packets are there. So this information is manually entered is very difficult. It may get a mechanical error or it get man failure should be happens over there. So to overcome those kind of scenario issues, we are moving the situation into dynamic routing algorithm. So this dynamic routing algorithm is update the situation based upon the information is transmitted the shortest path mechanism. That information is updated periodically by choosing the dynamic routing protocol. So in the dynamic routing protocol, we have n number of protocols are there, that we calling as a RIP protocol or OSPF protocol, or else we having as a BGP protocol. Apparently we calling as a broader gateway protocol, and we having as different kind of protocol services are there. So that we discuss in the next sessions. So what is the design goals of this routing algorithm? So if we design this routing algorithm, what is our main motivation, main intention to this design this goals, design of goals of this routing algorithm? So first one is this should be optimality, simplicity, which means a low overhead values, and stability values. We need to maintain the scalability, stability, and we need to maintain the granularity as well. So which means we go for this a rapid convergence as well as flexibility. For example, when you design this any kind of routing algorithm, the information is transmitted from source to destination is there. So here we have to choose the periodical manner values and periodical structure values only, which means easily we able to develop the value. And for example, we having as a multiple directions are there, so we have to go for this optimality, we have that one, we have to go for this granularity level, we have to maintain the stability level. So we have to quickly grab the levels, we have to quickly analyze the what is the shortest path, how much distance between a to b value and how much distance between a to c value. We having as a quicker time we are using that. When we choose the rapid amount of time value, we choose this for the shortest path or this for the shortest path. So if this path length is very high, we quickly move into the next path. So that kind of mechanism, that kind of developing algorithm, we choose that one. That is a major goals of this routing algorithm. So when go for this routing algorithm, but how we are able to choose the algorithm, what kind of classifications are there in this routing algorithm? So in the routing algorithm, we have several different ways are there. While for example, we develop the routing algorithm, information is transmitted, we have several ways we have developed that one. First one is a static one, other one is dynamic one. So as we discussed in previously, static, which means a non-adaptive mechanism, which means a manually we are go for this static mechanism, that is very difficult for this higher end server we are using, higher end routers we are using that one. But what is dynamic one? Dynamic one is it is updated periodically based upon the tool we are using that one, based upon the software upgradation we are using that one. The information is updated automatically in the periodical manner only. That is the dynamic manner. So in the routing algorithm, generally we have two things are there. One is static one, another one is dynamic one. Static should be the manual one. Very limited kind of operations we can do easily. But if you go for this higher end kind of calculations, higher end of routers we are using that one, that kind of things, it is very difficult to maintain the routing table. To overcome those scenarios, we are using this dynamic one, which means here the router's information is updated periodically manner. That is advantage of this dynamic one. So while coming to this one, in the routers, router is a networking device that forward the packets from one computer to another computer or one network to another network. So if we go for this one, multiple routers are there, multiple networks are there, that is also we can able to choose the information. So routers can able to manage the situations to information is transmitted to connect the routers to different network as well. And what kind of routing table we are using that one? Routing table thing, but a set of rules which use in table format, which in the Excel kind of format structure we are using that one, that use to determine so what kind of data packet is traveling over the internet protocol, so that will be directed. So for example, here the routing table is similar like this only. We having a routing table B, C, D. So I need information is transmitted from B to A to D. So A is my transmitter and D is my destination. So which path I'm choosing that one? So if you go for this A to B path, the packet distance is 2. If you go for this A to C path, the distance is 3. Others number the distance is 2. What is the value? We have that one. Either be less 12 or movable value. So here we have direction like this, A to B and A to C, and destination direction is A to D. So here I need information. I need to transmit information like this. Right. So here I maintain the one kind of routing table which is A, B, C and D value. So if information is transmitted from A to B, the direction should be and the distance should be 2, and information from A to C, the distance may be a 3. So in this scenario, I'll choose the path of A to B. I'll make a note of this. The next direction should be A to B. The packet size should be 2. And next one, what direction next to B to D? We having as a values which is A to B and B to D. The value should be 2 plus 2 value, or else what is the value which is 4 value. For example, so these values, for example, B to D is there, and my destination is some kind of value. For example, E value is there, and here we having multiple directions are there, and F value is there. So we need to maintain next one D to E value, next E to F value. We have to calculate all the values. So in the table which contains all the informations are for the router information, the packet information which is based upon the router, data is moving from A to destination point, source to destination point, based upon internet protocol we are using that one. With the help of that one, we can able to form the table that in the table format. But what is the advantage of this static routing, and what is the advantage of the dynamic routing, and what is disadvantage of this one? How we are able to overcome that one? What is static routing? So it is a manual entry. So minimal CPU memory is required, because in the backend there is no algorithm is required. So minimal entries is required, minimal CPU memory is required, and the granular control or how the traffic is routed, because we need to maintain the manual entry. We can able to grab them, we can able to look into the granularity and how kind of traffic structure is moving and what kind of routing mechanism are moving, that we can able to analyze that one. And this is very simple and configure, and we can easily maintain that one. But if n number of routers are increases, that there is difficulty for that one, and it is should be secured, only defined, because while you go for this, before data is transmitted, we have defined our routers, what kind of router we are using that one. So that should be, we go for the secured manner that can be accessed that one. And this bandwidth is not used for sending the routing updates, because this bandwidth is used for information transmit only, not used for sending the routing update. But what's disadvantage? So all these are based upon the manual entry structure, so that is a major disadvantage. If you are using 10 plus routers or 1000 plus routers, because while we are establishing the large kind of architecture, we have to maintain that kind of thing. It is very difficult, so manual update is not possible in this scenario. And this one, explicit addition of routers of all network values only. We have to explicitly, we are using the what additions of network, we are using that one. So that also we are not can't able to use that one. That's a major disadvantage. And this should be impractical for this large network. This is practical for this minimum of network usage value, 10 plus kind of routers we can able to use that one. But more than this 10 plus or 100 plus routers, it is very difficult, because if you go for this 100 plus routers are there, we can able to emerge, you can able to develop a large network architecture. That is difficult. But to overcome those kind of scenarios, we go for this dynamic routing. Dynamic routing is very simple and a configure into a large network. So while using a static network, that is very simple, and this is go for this a prescribed a minimal router kind of structure, but this is go for this a large kind of network is visible over here. And here we'll dynamically choose different routers where data link is goes down. So that is also possible, because dynamically the system is moving ups and down. That is also possible over here. And here we are maintaining the load balance between the multiple links. So how we are able to manage the load balance? For example, choose the path between the routers, and that is we can able to choose the multiple links or multiple movements, or we can able to grab the information in the table structure manner, that we can able to manage the load balance level as well. But we having as a disadvantage are there. What's disadvantage? So while maintaining the updates are shared between routers, so we are go for this consuming the bandwidth. In the previously static routing, the bandwidth is specifically using for this information transmitted. That is not used for the informations or the updates or shared information to router. We are not using the bandwidth. But in this one, we are using that scenario as well, because in some scenarios we get the acknowledgement kind of service also we are using that one. So on that time we are using some kind of specific bandwidth. So here the bandwidth is we are using that one. So that is consuming my information, consuming my bandwidth. And so this routing protocol, what can I put additional load on the routers, because while running the continuously manner in the what kind of structure we are using that one, where the information is continuously run in the backend perspective, that should be additionally add on load to the my RAM mechanism, the CPU server only. And here this is the best choice in hand in the routing protocol, and that is not in the administrator. So systematically, more than manually, systematically under the shortest path, the information is transmitted through that path. So manual entry is not applicable. Even administrator also can't do anything in this situation. That is a major disadvantage in the dynamic routing. But while discussing about this intra-network and inter-network, so we having as within the network region is there, and outside the network is there. So we'll go for this routing mechanism. Inside the mechanism, inside the autonomous system is referred as a intra-domain, but outside the system we calling as a inter-domain. So while information in the network layer, information is transmitting from one network layer to another network layer, another network region. So here we are possibility of this inter-domain is there, as well as inter-domain is there. There is a possibility of chance of information is transmitted within the network based upon the IP addressing mechanism. Same way in the outside network we are using the logical addressing mechanism. That is feasibility we have in the network layer. So I conclude this session. So in this session we are analyzing the what kind of routing algorithms are there. So we based upon the information is transmitted from source to destination, either we are choosing for static algorithm or we go for this a dynamic algorithm. So that kind of feasibility we have that one. So that we calling as a routing algorithm. So in the upcoming session we discussing about this routing protocol. So what is routing protocol? So while developing this kind of architecture, while developing this kind of a static algorithm or dynamic routing algorithm, we are go for a specific protocols are there to implement that kind of services, that we are going to discuss in the next session, that is a routing protocol session. Thank you.